Okay, everyone, welcome to Vertical Slice Architecture. I am Matthias Satz. I will be your host for this talk. And so thank you for joining. Let's start talking about a little about me. I am Matthias Satz, as I said earlier. I'm a software engineer. And oh, jeez, sorry. This is maybe awkward. Yeah, no, that's better. Okay. As I was saying, I'm a software engineer based in Buenos Aires. I've been working at Cognizant Softvision for around a year now. And I can really say at this point that this year has been like the best year for me in my entire career in software development. So join us, okay? Well, you have my email there, matthias.sats@softvision.com, in case you want to drop by an email or question or comment or feedback. I will try to answer you as soon as possible. So without further ado, let's jump in and talk about what is vertical slice architecture and why does it sound so cool, right? Vertical slice. Okay. First of all, I want to talk to you about most traditional architectures that we may be using whenever we use ASP.NET or ASP.NET Core or just plain C# with Net Framework. We've been working with several of these tiered architectures. For instance, I have clean and I have N-tier architecture from wherever, maybe from a DDD perspective, you know, where I have UI layer, service layer, domain layers, and also database or repositories or data access logic. So these type of architectures, they are kind of monolithic in its approach, not in the architecture as well. Because what they're making is they're using layers as maybe as the way of organizing things. So there's no problem with it because they took us to this point, like 2020, and this started to grow in early 2000, I think. But the main problem with this type of architectures, or maybe this flaw in the design, is that they're really only appropriate in like minority of the typical requests in the system. So these layer architectures, they tend to have some rigid rules around dependency management. You usually tend to end with a lot of abstractions around some concepts that maybe shouldn't be abstracted. Like for instance, maybe you have, let's say, a controller, and that controller may talk to a service, and that service to a repository. But these relationships are very stretched. You know, you can't just, I don't know, you can have a controller talking to a repository like directly. So these rules, they force us to organize our files into horizontal layers that will stretch during the entire application. Like I said, there's no problem with it, but they doesn't guarantee any clean result at the end. Just take, for instance, if you ever work with these architectures over a time span, like for, let's say, 10 years, if your application grew and got complex, it's kind of unmaintainable at this point with so many abstractions and layers. So that's why I say layers are useful until our system grows and gets complex. Because we then start taking this snowball effect. It's growing and it's unmaintainable, and you start to accumulate a lot of technical debt, and it's not pretty, not at all. So let's think in a more, let's say, practical way. So I have here a project view, a really simple project view of a common ASP.NET boilerplate project, sorry, when using tiered architectures. And this is, well, this is really basic, right? But think in a large application where you have like 4 or 5 projects, and whenever you need to to make a modification in the system, you need to touch a lot of files. For instance, if I want to add, let's say, an input to a form here, I will have at least 4 or 5 changes. And when we usually touch a lot of files, we incur into some kind of risk of, first of all, we may be breaking some others' functionality, because maybe we have a lot of logic pushed into, let's say, a controller, and maybe you are sharing that controller with other teammates. So you may be breaking another's one code. And also, you maybe have these basic merge issues when touching so many files. So it's gets tough with time. So let's move on into, so let's have a look on, let's go a step back and look at how our users interact with the system and how we developers change the system. Because users don't really care about this layer thing. No, it's obvious. But instead of what they're doing is they're using our system, they're interacting within a vertical slice. They go vertical, they don't care about layers. They just use a functionality, and they don't care about other things. So why can developers do the same? Why can we work on these vertical slices with these different kinds of behavior in the system? So in this case, let's say I have different behaviors that are going out of my system. For instance, I have this kind of flight, booking flight application, and these are my behaviors. I can either search flight, I can book flight, or I can even cancel a flight. So in this case, if I have different behaviors going out to my system, I could just work within one area and make sure that I don't affect any other kind of feature going on in the system. So this leads us to what Jimmy Bogart called vertical slice architecture, because we model and organize the application architecture around this axis of change, or better called vertical slices. As we talked earlier, we were kind of forced to organize our files by type. Let's say, I don't know, my data access logic goes here and my controllers go there, and maybe I have some helpers over there. And it's okay, but why can't we have everything in one single place? Why can't we have everything related to a single functionality in one single place? That would be so much helpful, right? So that's where these vertical slices became. So let's talk about implementing a vertical slice. We're gonna do some kind of overview about this, because, well, as we talked before, we want to, a vertical slice, it's all about taking all these different things related to a single feature, or maybe a single request, or an action, or behavior in my system. And we want to move all those things related to a specific action into one specific place. And this will start to lead us to start raking these layered classes that we have across different slices or requests. For instance, I have this kind of domain service from flight service, and I have all these different methods of different kinds of things you can do within that domain. I can either search for a flight, I can book a flight, or I can cancel a flight. Who wants to cancel a flight, right? But when we look at the use cases of this, how many times we use this within a single request? Like how many times I maybe use 2 or 3 of these methods in a single request? Probably never. So it doesn't make really much sense to have all this logic pushed together in one class. So what if we take these individual things and break each one of these into individual classes? So each of these individual classes now will represent actions that we can do in our system based on the overall of the application is allowing us to perform, right? So we're taking this long class and making a single, out of a single method, we will make a single class, which will represent action we can perform in the system. So as we start going towards this approach, we are not doing anything so magic right now. We are just using some basic refactoring techniques, right? We're just extracting our methods into classes. So what will start to happen here, if we don't see a whole picture here, is that these classes will have like a lot of similarities, but also they will have like these pointless divergences between them. So as each one of them are built individually, we may have to lose this vision towards the whole, right? We're going to lose some consistency there. So what's really going here is that our application will accept requests and will return responses, as most of the HTTP protocol or requests we're doing, right? So each of these different classes will represent the ability to make some sort of request to my system and to do something and return some sort of response, let's say. So we need to model this explicitly. As I said, we have a request coming in and a response coming out. And this may look maybe obvious or simple, but we need this kind of this common interface around all different requests. So Jimmy Bogart built an open source library called Mediator, which basically will implement the mediator pattern of a request coming in, which will represent with this iRequest of T. It will go into this handler, which is the iRequest handler of T, and return a T response, okay, where T is the type of the response. So we will have like one object for each one of these, and there's some sort of code here, like how a handler looks. As you can see, it takes a T request and will return a task of T response. And we are doing task because we're using async, not because we're cool, but because we're gentle. So moving on with these requests, we're going using CQRS for the sake of these requests. And CQRS basically at its most basic form, it's where I have two objects to represent commands and queries, where before we had one model to communicate with the database, right? As a side note, we have a more detailed CQRS tech talk from past year Programmers Week from Lucas Luna. You can take a look at that. But basically, CQRS, it's about splitting our models for reading, either from reading from writing data or updating resources. So I can have my queries, which will act as a get or as a fetch of resource from my server. And I will have also commands, which will represent any kind of action, such as post, put, batch, you name it. Whatever action that makes a change in my web app will be using commands. And commands will also have this kind of bodies. They're kind of different of the requests, of the queries, sorry. So a query could be translated on some kind of object to represent what kind of information I'm asking to a handler, and saying, okay, now you need to get that information, and the response is like, okay, now how do I ever turn that information back to the user in response? It's a similar thing as the post and the command that has a request to perform some operation to a handler to do the thing that we want to do, like for instance, creating a resource or updating something, and then finally some response, whether this is what's successful or not, right? So we want to make sure that all of our inputs required to be able to perform an operation are represented in those incoming models, and all the information needed to be able to get back to the user is going to be in our response. So on the other side, we have one model in and one model out. Okay, so I have one request, either a query or command, going in, and I will have always a response coming out. So our main goal here is not to share these different queries and commands or handlers between individual requests. We want to have each one of these is isolated, right? That's the main point here. So that means that an individual request has some sort of object coming, and we don't really care what's going on. It's just getting handled by some handler, and then finally there's some kind of response on the other side. So we have this complete encapsulation over whatever work is going to be done underneath the covers here. So let's have this quick look at and how we model a request or a query request. I'm going to show you for the time. I'm going to show you the query. Okay, the query side, the command side, it's kind of similar. They had some implications and changes, but let's talk about the query. So how do we model these incoming queries? So we need a type that represents a request for information. So first things first, we have these simple queries. We have a specific request for information, and we don't have to provide any additional information along with that request. So in this case, on the left side, I have the empty type. There's nothing else you need to know other than the type of the request to be able to get the overall response, right? Now, one of the things we're doing here, as well as organizing these requests and response objects in this some kind of request response hierarchy of the system. So in this case, there's this get all page on some overall set of functionality, and so making sure that this functionality, this request, is completely inside of that overall set of requests. And sometimes may do inner classes like this time, or other times we can add some organizational folders. But we want to make sure this class was very close to everything else that deal with whatever that query is going to be. So there are times that things may get more complex, right? If I look at individual requests and say, well, how can things get more complicated? Well, sometimes there's maybe like parameters to my query. So this could be like query string parameters, for instance, with web applications. So what I do is take all other inputs to be able to handle that query and model those as individual properties on my overall query, as you can see on the right side. So this web request has to have these query string parameters, and those are just simply represented as individual data properties on my query object. So moving on into responses. So as I have a type for the queries, I will have also a type for responses. So this type represents a request for information. So the first thing we had were very simple queries. So a simple query, let's say, may have a simple response, right? Maybe I am just fetching all the data from, let's say, these flights. So I have these two kinds of response, right? Whereas I can return you like basic information about this flight, or I can either have complex responses, right? And by complex, I mean I'm using inner types into the class, just to ensure that that class is completely isolated and I don't break any other's code or no one breaks my code. So that's why in my detail read model, I have these inner classes put together as they're more complex. So let's talk about query handlers. So the mean of the application are going to be inside this, like the most logic will be inside these individual handlers. So initially, what we did when we started modeling these handlers, we just have to go back together and defactor first, and then we're going to refactor this into a handler. Like if you were using at least an MVC, you would have your logic in your controller or in your API or so, and we need that logic from whatever it's in your domain or your controller, put into the handler. So that code in there, I'm using, for instance, I'm using an ORM here to handle my request. So as you can see, my request comes in as a query request. I will fetch from my context or from whatever I need to fetch, and I will return that. So what I'm trying to say here with this kind of handlers, these simple handlers, is that they're completely encapsulated. We kind of isolate ourselves, and we also, as we are isolated, we have the freedom of fulfilling each request as we may know best, right? I could use, I don't know, I could use an ORM, I could use SQL projections as Jimmy Bogart uses with Automapper. It doesn't really matter whatever I want to do inside my handler to be able to handle this query, because it's completely encapsulated inside of this individual object. So this will go into my ORM, for instance, to perform some work and to get the response. I could be using also stored procedures. I could be calling another handler, which will not be maybe sort of appropriate, or I could just be calling to another API, you name it. There's a lot of possibilities within this, this architecture, right? So that's basically a high-level view on how to apply this. So to summarize, we first we move or extract our core methods or service methods into these classes, and these classes will boil down into handlers, which will take in a request and will produce a response afterwards. So that's the main thing about vertical slices. It's having each of my behaviors of the system isolated one from another in vertical slices. Particularly, I like to separate these concerns in folders. So I can have my, let's say, my feature folder, and inside each of that, I have my features, my actions, and inside there, you can find your handler, your query request, your command request, maybe some validation, which I didn't talk about, but you can use, I don't know, fluent validation, for instance. And that's it. It's just having these handlers with a single request are producing a single response. And you will find yourselves with your team more confident on coding things that will work over time. The only downside, if I can say so, of this is that your teammates and you need to understand common refactoring techniques, as well as having this common sense of detecting code smells, as well as and when it needs to refactor. Because what will happen is maybe you start sharing a lot of logic between handlers, and there will be a point when you say, okay, maybe there's a lot of common code. Why don't we move this to a common folder and call that common to use it? Well, that's up to you. But the first rule will be like to not to share. If you can afford it, just try not to share code between the slices, as it will work best. So that's basically it. That was my overview about vertical slice architecture. Hope it was not too fast or didn't understood anything. This was my first tech talk, so sorry about that. If you have any questions, you can put it right now at the end. Rosina, you're there?
Yes, there is a question in the chat.
Okay.
It says, do every vertical slice you're creating have layers, business, data access, etc.?
No, not really, because we're trying to move that layer thing into single self-contained vertical slices. Like instead of having, let's say, my controller and my service and my domain and my model, I will have everything encapsulated in, let's say, a folder, for instance, and I will have all that code within a slice where I have my request, I will have my handler with my logic, and I will have my models also there, and my response, right? Because my response will be like tailored to the view. So that's it.
We don't have any other questions.
Okay. Okay. Well, hope you like it. I really enjoyed it. I was really nervous, but we got it, right? So thanks for joining. Thanks for your time, and hopefully see you in another Programmers Week next year. Thank you.